Chapter 3, Section 3 is about more practice with multi-step inequalities. Just a reminder, identity versus contradiction. When we were solving equations and we ended up with something that said that where our solution was like 5 equals 5, that had all real numbers for solutions. So that was called the identity, when all real numbers worked. And the contradiction was when we ended up with an answer and it was like 5 equals 0. That's contradictory. 5 does not equal 0. And this was no solutions. And we are going to have a couple of situations like that with inequalities where we might end up with something that says 1 is greater than 10. And if you end up with a statement like that that says 1 is greater than 10, then there will be no solutions once again. So first example, we only have to graph 1 to 3. We are going to start by subtracting 3x from both sides. And when we subtract 3x from both sides, you end up with a negative 2x is less than 8. From there, we can divide both sides by negative 2. Whenever you divide by a negative, you have to switch the sign around. And we end up with x. This less than sign is going to switch around to a greater than. And then 8 divided by negative 2 is negative 4. So 8 is greater than negative 4. Graphing that, we're going to have an open circle on negative 4. We want all the numbers that are bigger than negative 4, so we're going to have everything to the right colored in. Number 2, we have variables on both sides. If you get rid of a smaller variable, then you have less, you have to deal with less negatives. So if you look at 6 and 3.5, 3.5 is smaller. So you subtract negative 3.5x from both sides. And when you do that, 6 minus 3.5x, or 6x minus 3.5x, is 2.5x minus 1 is less than or equal to 4. Now we need to get rid of the subtract 1. So we are going to add 1 to both sides. And you end up with 2.5x is less than or equal to 5. And from there we divide both sides by 2.5. And we end up with x is less than or equal to 2. Graphing that, we're going to have a closed circle on the 2 and everything to the left-hand side. We want all the numbers that are smaller than 2. Number 3, we need to distribute first. 2 times k is 2k. 2 times negative 3 is negative 6. Be careful with your distributing there. And on this right-hand side, I'm going to simplify some things. I'm going to combine like terms. We have a 6 and we have a negative 3. So you can put those two things together. 6 subtract 3 is a 3 plus 3k. So all we've done so far is simplify. We distributed. And then we combine the 6 and the negative 3. Now look at your variables, the expressions that, or the terms that have the variables in them. You have a 3k and a 2k. Your 2k is smaller, so I'm going to start by subtracting that from both sides. And it works either way. If you get rid of the smaller one, you are less likely to have negatives. Careful of this symbol right here, that is a negative 6 is greater than 3 plus k. 3k minus 2k is k. And now subtracting 3 from both sides. Negative 6, subtract 3. You're $6 in the hole. You go $3 more in the hole. You end up with negative 9 is bigger than k. Now we cannot use this as an arrow this time because your variable's not on the left-hand side. If you want to rewrite that as k is smaller than negative 9, that's okay. Open circle on the negative 9, and we want all the numbers that are smaller than that. So be careful, that arrow thing only works when your variable's on the left-hand side. And those are the only 3 we need to graph. Number 4, there's a lot going on in this one. Let's start out by distributing right here. 2 times 3y is 6y. And then we have a 2 times a subtract 2, which is a subtract 4. We do not multiply this 2 times that subtract 4. You only multiply the 2 by what's inside the parentheses. So this subtract 4 we just write after we distributed. And on the right hand side, 3 times 2y is 6y, and then 3 times 7 is 21. On this left-hand side, we need to put these two numbers, we need to combine those first. You're at negative 4 and another negative 4. So you borrow $4 and then you borrow another $4. You are in the hole, $8. 6y minus 8 is greater than or equal to 6y plus 21. From here, we're going to subtract 6y from both sides, and you have negative 8 is greater than or equal to 21. Is negative 8 bigger than 21? Negative 8 is smaller than 21. So this is not a true statement. So in this case, there are no solutions. Negative 8 is not bigger than 21, so there are no solutions. And if you just want to write empty set, that's fine. Number 5, we need to distribute. 1/4 times p, you know what, let's change that to a decimal, will be 0.25p. 10 times 1/4 is 2.5. And don't forget about the subtract sign in there. And that is greater than 6 minus 4p. If you look at your variables right now, this one is a 0.25 and this is a negative 4. If we get rid of this negative 4, we will turn our variables into a positive. So we're going to add 4p to both sides. And then you have 4p plus 0.25 is 4.25p. So I added those two things together. Subtract 2.5 is greater than 6. From there we add 2.5 to both sides. And you are left with 4.25 is 4.25p is greater than 8.5. And when you divide both sides by 4.25, these cancel out, and you are left with p is greater than 8.5 divided by 4.25 is a 2. So p is greater than 2. Number 6, let's start with our variables. 4n and a 1/3 n. So we are going to subtract 1/3 n from both sides. And if you want to write that as a decimal, it's fine. That's 0.3 repeating. These will cancel out, and you will have 1/2 is greater than or equal to 2/3. And then when we combine the ends, 4 minus 1/3, or 4 minus 0.3 repeating, will be 3 2/3 n, or 3.6 repeating. And now I'm going to change these. I'm going to make them have the same denominator. 1/2, if I multiply both of those by 3, we will have 3/6. And over here, if I multiply these both by 2, we will have 4/6. And I did that so that I can now add those two things. To get rid of this 4/6, we are going to subtract 4/6 from both sides. And after that, 3/6 minus 4/6 is a negative 1/6, which is greater than or equal to 3 2/3 n. If you have a calculator, you could divide by 3 2/3. Since I don't have a calculator, I am going to change that. 3 times 3 is 9, plus 2 is 11/3 n. To get rid of that 11/3, we're going to multiply both sides by 3 over 11. And we will end up with negative 3 over 66 is greater than or equal to n. And negative 3 over 66 reduces to negative 1 over 22 is greater than or equal to n.